In this video, we'll write the balanced net ionic equation for CuCO3 plus H2SO4. This is copper to carbonate plus sulfuric acid. So the first thing we need to do is balance the molecular equation. We look at the molecular equation, it's already balanced, so we don't have to do that, which is nice. Next, we'll look at the state for each substance here. So copper to carbonate, when we put this in water, it'll actually react with water. So we're going to say that copper to carbonate is going to be a solid. We'll use solid copper to carbonate. We'll add it to this sulfuric acid, which is a strong acid. So that's going to be aqueous. That's going to be dissociated into its ions in water. Then copper to sulfate, very soluble. That's going to be aqueous. And then we have a gas for the carbon dioxide. Let's call the water a liquid. So we have our states here. We can now split the strong electrolytes into ions, and this is going to be the complete ionic equation. So this is a solid. We don't split solids apart when we do net ionic equations, so we're just going to keep that as this copper to carbonate together. I'll write the states at the end. Plus, then we have hydrogen group 1 on the periodic table that has a 1 plus ionic charge. The sulfate, the whole sulfate ion, is 2 minus. We'll have 2 of the hydrogen ions then, 2H plus, and then we'll have the sulfate ion, SO4, 2 minus. So those will be the reactants in our net ionic equation. For the products, we don't know what copper is, but we do know that sulfate ion is 2 minus. Good one to remember. So the copper has to be 2 plus. So we have our copper 2 ion, and then we have a sulfate ion, that SO4, 2 minus. And with net ionic equations, we don't split gases or liquids apart. So we'll have CO2 and then H2O. This is the complete ionic equation. Now we can cross out the spectator ions. They're on both sides. So we have our reactants here and then our products. I can see I have a sulfate ion here in the reactants and in the products. So that's a spectator ion. I'm going to cross that out. And that's the only thing that's the same on both sides. So this is our net ionic equation for CuCO3 plus H2SO4. Let me clean it up and add the states in, and we'll have our net ionic equation. So this is the balanced net ionic equation for copper to carbonate plus sulfuric acid. You'll note that charge is conserved. We have 2 times 1 plus. So over on the reactant side, we have a 2 plus. On the product side, we have 2 plus. Charge is balanced. And if you count the atoms up, they're balanced as well. This is Dr. B with the balanced net ionic equation for CuCO3 plus H2SO4. Thanks for watching.